All right, you guys, here we go for part 2. We are going to talk about adding and subtracting rationals. All right. This, in my opinion, is a little bit more difficult than multiplying and dividing, because the big thing that you have to do is you have to get a common denominator. Okay, which is can be kind of tricky. Once you get your common denominator and you combine them together, you can try to simplify it. Like most of them aren't really going to simplify, but check it out. Okay, so if I have 18x3, 18x3, that already has a common denominator of 18x to the third. The one thing I want you guys to be really careful about is whenever you see a minus sign, you got to pay close attention, because you actually need to distribute the negative. Okay, so I'm going to end up getting, let's see, x plus 5y minus x plus 3y when I distributed the negative. Okay, now I need to go ahead and combine like terms. So I've got x minus x. That's going to give me 0. And then I got 5y plus 3y. That's going to give me 8y. Okay. Now, that answer is okay. Also, though, you could say, oh, well, now I can reduce the 8 and the 18. 2 goes into that 4 times and 9 times. So maybe it's better to put like 4y over 9x to the third to just get it simplified all the way down. All right. So that's how we're going to do the adding and subtracting problems. Okay, let's take a look at number 16. Now, this side has an m plus 5. So that side needs it. This side has a 6. So that side needs it. So what we're trying to do is just get these to be the same. All right. And now I have a common denominator of 6m plus 5. And then on the top, I distribute. Okay, I will get 6m minus 24. And then on this one, plus 6m squared plus 30m. Okay? And it's over 6m plus 5. And when I combine all my like terms, I'm actually going to put this one first because that's m squared. But these are the ones that combine 6m and 30m, okay? So that's going to give me 36m minus 24. All right? Now, we're pretty good with that. The one thing that you can do, again, let me like move this over here. Okay, I can actually factor a 6 out of the top. You guys see that? And there's already a 6 out of the bottom. And so the 6's can cancel out. And then that simplifies it even more. And then I can put my final answer just with that. Okay, let's check out number 17. All right, you guys, on this side, I have 3x plus 5. So that needs to go on this side. On this side, I have x plus 6, so that needs to go on this side. So my denominator is 3x plus 5, x plus 6. You're never going to multiply that out, okay? I do want to multiply out the top part, though. And if you look here, when I distribute that, I am going to get 6x squared plus 10x, okay? Yeah. Now, when I do this, when I multiply this, because it's a binomial times a binomial, something with 2 terms times something with 2 terms, I actually have to do FOIL. Sorry, but that's what we got to do. Now, you guys, I'm going to go ahead and do FOIL right over here. I'm going to use the box. If you don't want to use the box, don't use the box, but I'm going to use the box. 5x minus 5 times x plus 6. Here's what I get. Okay, 5x squared, right, plus 30x minus 5x minus 30. And when you're using the box, almost always like you can combine those two right here. Okay, so this becomes 5x squared. 30 minus 5 is plus 25x minus 30. Okay, so all together, all right, okay, I can combine a 6x squared and a 5x squared. That's 11x squared. I can combine a 10x and a 25x. That's 35x minus 30. All right. I highly doubt that that factors. We're just going to pretend like it doesn't and say that's good because I'm not trying to mess with that. All right. So there's your answer for number 17. And now let's take a look at number 18. Okay. On this side, I have a 4. So this side needs a 4. This side I have a 2n plus 6. So this side needs a 2n plus 6 right over here. Okay. On the bottom then, I have 4 and 2n plus 6. On the top, I get 10n squared plus 30n. Okay. And then I got to distribute the 4. But kind of be careful because I got to distribute the negative also. So if I have to distribute a negative and a 4, let me do them at the same time. That's going to be minus 4n minus 12. Okay. So I have 10n squared. If I combine those, that's going to be 26n minus 12. Okay. I guess you could take a 2 out of the top. So it's like 5n squared plus 13n minus 6. And like technically, you guys, I'll just tell you this. If you didn't do this, it's okay. But you can take a 2 out of the bottom as well. Now, when I take it out, if I take a 2 out and put it with the 4, that's going to give me an 8 on the outside. Okay? And then 2 and 8 will cancel to 1 and 4. All right? And I get 5n squared plus 13n minus 6 over 4n plus 3. Okay? Now, I'm pretty sure anything I'm going to put on the test, I don't think I'm going to have it like factor down a ton more than that. However, this particular problem does factor down, so just like I'll show you. But again, if you didn't get this, like don't stress about it. Okay, look, negative 30, 13. This is multiplies, nope, not 10 and 3, because that would multiply to make positive 30 and can't give me positive 13. It would be 15 minus 2. But then here's the thing. Because there's a 5 in front, this ends up factoring to, okay, this part right here is plus 3. This part right here is 5n minus 2. And then on the bottom is 4n plus 3. And would you look at that, that actually crosses out. So, I mean, that's kind of cool. It does simplify quite a bit. I'm really going to try to keep the adding and subtracting questions on your test, though, like pretty low-key, you know? So there's not like too much stuff going on, just to make sure you can get common denominators. Okay? Okay. Next, let's talk about solving. All right? Okay, when I'm solving, I want to take a look at everything that's on the bottom and make an LCM. And if you guys look, the bottom has a 2, a 2x, and an x. Okay? So my LCM is a 2 from that, and an x from that and that. And I don't have to write it twice. I'm good to just put 2x. Okay, now I'm going to multiply every single term by 2x. All right, here we go. 2's cancel out. That just gives me x. 2x and 2x cancel out. That gives me 1. And the x's cancel out, and that gives me 2. All right, this one's pretty straightforward. It's just a linear. okay, equation. And to solve for x, I'm going to just add 1 to both sides. And so I get x equals 3. All right. Okay, now let's see what the LCM is of number 20. Now here's the thing, guys. Before I start, like especially that and that, you guys can see that those factor, right? I'm going to go ahead and do that. I'm going to use r plus 3 here and r plus 3 here. Okay, so I'm actually not going to use those. Now, what this tells me is that my LCM is r. They all have an r in it, okay? And then r plus 3, because those two have an r plus 3. Okay, so next to every problem, I go r plus 3, r plus 3, r plus 3. All right, check it out. Here, the r's cancel, so I get r plus 3. Here, everything cancels, so I get a 1. And here, everything cancels, so I get a 2. If I combine those together, r plus 4 is 2. Subtract 4 from both sides. Okay, r equals -2. All right. Cool. Okay, let's look at 21. By the way, if I'm checking to see if these are excluded values, remember we talked about this? I can plug 3 in. It's cool. It doesn't make the bottom 0 of anything. I can plug -2 in. That also doesn't make the bottom 0. So that's okay. So we're going to kind of look for these excluded values as we go. All right. Okay. This one is, okay, it's got a 5 and it's got an a squared. So it's just 5a squared. So I'm going to do that by everything. Okay. Here, the 5's cross out, so I get a squared. Here, everything crosses out, so I get 1. And here, the a squareds cross out. I do have to distribute this. I get 5a plus 15. All right? Now, here's the thing, guys. If you're left with an equation that has a squared in it, that means we have to factor to solve it. That's the only way to solve squareds, right? So what I want to do is I want to bring everything over to this side where this a squared is. So it says this, a squared. Okay, I'm going to subtract the 5a. Now, it doesn't really combine with anything, so I'll go ahead and just put minus 5a. And then I'm going to subtract the 15. So then I'm going to put minus 14. And then I'm like, oh, cool, I know how to solve this because this is a factoring problem. All right. Okay, so I get, let's see, multiplies make 14, 7 and 2, minus 7 plus 2. And so my solutions, if I solve that, I get 7. And if I solve that, I get -2. Okay? Now, I do need to check my solutions. If I plug 7 into the bottom, I'm good. If I plug -2 into the bottom, I'm good. So those are both answers. All right? Okay, now let's check out this last one. You guys might notice that factors x squared minus 9 is x plus 3, x minus 3. Okay, so I'm actually not going to look at that. Now, that tells me that my LCM is x plus 3, x minus 3, because that covers like everything on all the different ones. All right, I'm going to multiply that by every single term. Okay, x plus 3, x minus 3, x plus 3, x minus 3, x plus 3, x minus 3. Okay, here we go. Cancel, cancel. I'm going to go ahead and distribute that right now. That's going to give you 6x plus 18. Cancel, cancel. That'll give me 8x squared. cancel, cancel. I got to distribute this. Now, be careful. There's a negative right there, okay? So it's negative 4x squared. Negative times negative is plus, negative 4x squared plus 12x. Okay? Before I start moving things around, let me put those together. So 8x squared minus 4x squared, that's 4x squared plus 12x. Now, I am going to bring the 6x over. Okay, so that is going to give me, okay, so 4x squared plus 6x, and I am going to bring the 18 over. So that will give me minus 18. And this is what I have to solve in order to, figure out my solutions. I got to factor this, okay? Okay, before I start, 4, 6, and 18 all divide by 2, okay? So I'm going to get 2, and then 2x squared plus 3x minus 9. And then I'm going to do the bottoms up thing, right? Okay, 2 times 9 is 18. What multiplies to make 18 and subtracts to make 3? I'm going to get positive 6, negative 3. I'm going to divide both of those by 2. And so this factors to make x plus, right here, 3. And then right here, that does not reduce down, so that becomes 2x minus 3. And if I solve those, okay, right here, I end up getting negative 3. Right here, I get, okay, 2x equals 3 if I add it over and divide by 2. So x equals 3 over 2. Okay? Let me just erase that because I'm running out of room. So x equals negative 3 and 3 over 2. And then my last step is just checking to make sure if either of those are extraneous solutions, right? Fake solutions that don't work. Okay, now if I go back up to the bottom and I look at, let me erase a couple of this stuff here. Okay, if I plug in negative 3, right here, I'm fine. But what if I plug it in right here? I'm dividing by 0, and that is no good. So that is not an answer. But 3 over 2, I'm okay. So that is an answer. All right, so that's kind of what you got to do with the solving equations. Okay, perfect. Let's see here. Last but not least, let's look at some graphing problems. All right. Now, from what I was talking to you guys about today, the first thing that I want you to do is factor as much as possible if you can. So like here, it's negative 3, negative 4. Okay. And then on the bottom, let me just do it over here. That's going to be negative 4 plus 3. All right. Do you guys see that the minus 4s cancel out? Whenever you have something that cancels out, that's a hole in the graph. The hole is whatever would have made that term 0, because like if I have x minus 4 over x minus 4, whatever would make that 0, because 0 over 0 is where the holes are. All right. So in this case, it would be at 4. So I'm going to say there's a hole at x equals 4, because that's what I crossed out right here. Okay. So now I'm actually going to take this, make this a little bit smaller, and my new equation that I'm going to use to answer the rest of my questions is this. Okay? So let's go ahead and take a look. Remember, I'll have some reminders on the board for you. It goes like this. X-intercept is when the top equals 0. Well, the top equals 0 at 3. Y-intercept is when I plug in 0. Okay, if I plug in 0 here and here, I get negative 3 over 3. I get negative 1. All right, that's when I plug in 0. Okay, vertical asymptote is when the bottom equals 0. So that is going to be at -3. So I can go ahead and draw a vertical asymptote. Wait, let me make that a little bit bigger so you can see it better. At -3. Okay. And then my horizontal asymptote, you guys remember that you just compare the top to the bottom. Now you can do it on this one or you can do it on this one. It doesn't matter. Both of them are the same. It's either x squared or xx. That's the same. So the coefficients are 1 and 1. So my horizontal asymptote is at y equals 1. Let me go ahead and make that asymptote. Okay. And now I'm ready to draw it. Whoops. Here we go. All right, now I'm ready to draw this. So you can see that this part would definitely go right down there because there's 2 points there. Now, the other side, to figure out where it's going to go, I need to plug in a number. I can plug in -4, -5, -6, -7, -8. I can plug in whatever, okay? I will go ahead and plug in -4. And I'm plugging it into this equation right here. Okay, -4 minus 3 is -7. -4 plus 3 is -1, which is 7. So -4 is up at 7. So can you guys see that that part of the graph will go through like this? Okay. Last thing I need to do is if it does have a hole, I want to take, let's see, there's a hole at 4. Once you graph everything else, go to the 4 and just put a little hole right there. All right, because that's actually part of your graph. Okay. All right, nice. Last one. Let's see here. Okay, clean that up a little bit. All right, on the top, I can factor out a 3. On the bottom, if I do the x thing, it's 3 times 2, -3 plus 2. Okay? My x minus 3's cancel out, which means I have a hole at 3, because it says -3, okay? I've got a hole at 3. And then the equation that I'm actually going to be working with is whatever's left. Well, there's a 3 on the top and an x plus 2 on the bottom. So that's what I'm going to be working with for the rest of my problem. All right. Here we go. X-intercept is when the top is 0. There is none. This one won't have one. Okay. Y-intercept is when I plug in 0. This will have one because it'll give me 3 over 0 plus 2. So 3 over 2 or 1.5. It's like there, I guess. Okay, vertical asymptote is where the bottom equals 0. So that's going to be at -2. So let's make that. All right. And then horizontal asymptote. Remember that that's the rules where I look at how many x's are on the top and the bottom. You can look here or you can look here. In either case, the bottom has more x's than the top. They're not equal. The bottom has more. So it's at y equals 0. And I'm going to go ahead and put that one down. Okay. Now it's time to draw it. I mean, I can definitely see that up here is that part, right? Okay, I mean, they're usually opposite, but let's just check and make sure. Okay, for this side, I can plug in -3, -4, -5, -6, -7, -8, whatever. I will plug in -4. Why not? All right. So if I am plugging into here, -4, I will get 3 and -4 plus 2, which is 3 over -2, which is -1.5. Let's look right there. And so, yeah, it does come right down here, go that way. All right. And then the very last thing I need to do is there's a hole at x equals 3. So I go to x equals 3, put a hole in my graph. All right. So hopefully that makes sense. If everything there made sense to you, you guys are going to do awesome on this test. Okay? Great job.